In this video, we're going to look at a simulation in Excel of a die rolling game called Pig. And this is based on a video from a Numberphile video called The Math of Being a Greedy Pig. And so here's that video. And Pig is a die rolling game. So a player rolls a die, and if they roll a one in that first roll in a round, then the score is 0 and they're done, and it's the next player's turn. But if they roll something other than a one, then they are allowed to continue, and their score for the round will be the sum of the rolls in that round, provided that they've stopped rolling before they roll a one. If they roll a one in anywhere within a round, their score is 0 for that round. So they want to sort of push their limits and roll as many times and not get a one. But so the more times they roll, the more likely it is that they get a one, but it also, their score is higher if they roll more. So it's playing those two against each other. Okay. In the video, they do a simulation. I think it was in Python probably. And the simulation that you see on the graph here in the video was a comparison of strategies. So they proposed a strategy, and they did other things as well, but they proposed a strategy where the player stopped when there's the sum for a particular round was a number, let's say 18. So if you rolled an 18, then stop. And if that's your strategy, then they did a comparison of strategies. So they did a big simulation, a comparison of strategies, and for them, and then they found the best strategy was a score of 20, and it was very sort of broadly distributed. So it was, very 19 and 21 were quite close to 20. Okay. So I'm doing Excel here. So it is got some limitations in Excel, but I want to sort of and I'm not going to simulate a strategy. I'm just going to roll dice and sort of sum up die until I roll a one, and then from then on it's 0. And I just want to see sort of, I don't know, round by round what that number was. So I don't have a strategy where I'm stopping. I'm just going to sort of play until I lose and then take a step backwards and see what that sum was. Okay. So, and I'm doing that in Excel. Okay. So just sort of some excuse to play around with Excel, but also get some feel for this game. This first row 3 here is just the count. So I put in a 1, I put in a 2, I highlight the 1 and the 2, I get the sort of move down into the right-hand corner there, get the sort of fill cursor and pull across. And I stopped at 51 because it fits on my screen nicely, but 2, they imagined playing in that other video, they imagined playing the game up to 100. You can't, so this is like one round. So this is saying, what if there were 50 rolls in one round? And that is sort of one, quite unlikely, but also they imagined going up to a score of playing up to 100. And so if you were going up to 100, then you can't score a 1 because a 1 makes you lose. Then the most rolls in a round of that game would be 50, because your lowest score for a round would be 2. And so 50 rolls of 2 would get you up to the 100 to win the game. Just another excuse for stopping at 50. Okay. So here we are in row 4, and this is just simulating 50 roles. So in Excel, there's a function RANDBETWEEN. You give 2 arguments. It is, you get like integer numbers, and it is inclusive. So you will get ones, you will get, you can get ones, including ones and including sixes. Okay. And I just rolled 50. Forget the rules of the game. I just rolled in my simulation. I just rolled the die 50 times. I have another row. I have there are sort of 3 rows per, this is one sort of simulation. And then I have others. But so this is like one proposed round for a single player. Okay. So I have, or one sample, I guess that's the right word I'm looking for. So now here is my in play row. Again, I don't have something, I'm not programming Excel. I'm just sort of using Excel formula straight out of the box Excel formulas without any kind of coding. Okay. So I have a row here with variables, ones and zeros, that I'm saying I am in play. You know, could the person in this round keep going? And then the first round's always a little bit different from the other ones. So here in column B is the first roll, column C is the second. So for the first roll, I am in play if B4, the roll. So B4 is the roll, 5 is whether I'm in play or not, and then 6 is going to do the summing. And then B is my first roll, and C is my second roll. So I am in play which is B5, I'm in play if, and this is the first roll, if B4, the roll, is a 1, then 0, I am not in play. Otherwise, 1, I'm in play. Let me move over to the second roll in the round. So C is the second roll. And am I in play? Well, I start off by multiplying by B5. So I can only be in play for the second roll if I'm still in play after the first roll. So I'm multiplying by B5, and B5 is either 1 or 0. So if it was a 1, I'm in play, and I might possibly stay in play. If it's a 0, I'm multiplying by 0, and I will, once I'm out of play, I stay out of play. And so multiplying by 0 will always give me 0 and keep me out of play. Okay. Then what am I multiplying by the previous result? So if I look at the roll, C4. So C is the current roll, or I'm in roll 2. So I'm in play for roll 2 if I was in play after roll 1, and if for roll 2 I rolled a 1, then I'm multiplying by 0 and I'm out of play. Otherwise, it's a 1 and I'm in play. And that formula I can then copy over. So the first round is different, but every round after that is the same, and I can sort of copy that formula over. And this sort of gives me, so there it is, that same formula. This gives me the effect of like a while loop, sort of like this knows whether, so I did 50 iterations, so it's not like a while loop in that sense in terms of efficiency or anything like that. But I do know sort of, I'm still in play, I'm not in play. So I have some kind of the logic of a while loop to some extent. Okay. Now I have the quantity I'm interested in, the sum of the rolls, which is the player's score. And again, the first round is different. And so if B5, if I'm in play, I am going to B4, which is the roll, and otherwise 0. So this is not the roll, this is whether I'm in play. So if I'm in play, B5 equals 1. If I'm in play, then I'm getting that first roll, otherwise I'm getting 0. That was the first roll. What about the second roll? On the second roll, if I am in play, C5, so C is roll 2. 5 is in play. So if I'm in play, then I'm adding B6. B is roll 1, and row 6 is the sum. So I'm taking my sum from the previous roll and adding C4, which is the current roll, roll 2, and it's the actual roll for row 4 is the roll of the dice. So I'm adding to, so if I'm still in play, I'm adding to my previous sum the current roll. And if I'm not in play, then my score is 0. So, okay. And Excel is volatile, so every time if I enter a formula, especially and if I enter a formula with a RANDBETWEEN in it, then it will update. Okay, so we'll see the numbers flux. So then I put that across. So the in play and the sum work together. So as soon as the in play kicks out, so as soon as I roll 1, the in play kicks out and the sum kicks out. So here was my 1, and the in play roll kicked out and the sum kicked out. So how far did I get in this case? I rolled a 1. And it's random. So sometimes I get farther, sometimes I don't. Okay. And then what else did I do? So then I came along here in my max column and I found the maximum from of the sums. So B6 to AY6. That was the score. How well did I do before I'll say crapped out. That's a different game. Okay. And then I can use, Excel has a formula called match, and I can say, I'm looking for this to match the max. I'm looking for that match in that set of sums. And I'm looking for the 0 here means it's an exact match. So in what position in this row here? In general, it could be an array, but this is specifically just a row 6. So AZ was the max. So I'm looking for the max in this whole set, and I am looking for it to be an exact match. I know I'll find an exact match, and that ends up to be the number of rolls. So it was 1, 2, 3, 4, 5, 6, 7, 8, 9 rolls. So in this particular sample, I had 9 rolls and got up to 39 before I rolled that 1 and lost it all. Okay. And then, so I'm not performing a strategy. I'm just saying, play until you lose. Then imagine you had the perfect insight and went 1 back. And what score could you have gotten for this particular set of rolls? Okay. And then I am for this, and then let me show you that like in Excel, I did I went down to a little over 6,000, but each sample takes 3 rows, so I did about 2,000 samples, I guess. But if you have this, I can copy it down. It takes all three rows, and to get the max and the count, um, it takes all these columns and all these rows to have, for me to have a sample. But then if I copy down three, it's another sample. So I rolled a one almost immediately and got nothing. So that was not a great effort, but I can get more samples. Um, I didn't do a good job here in that my average, I specifically went down to a specific row rather than say add up everything below. So if I added, I have to adjust my average and standard deviations up here if I add more samples below. So I could either know to fix that or do a better job in doing this average. Okay, but this, so I had for each sample, I find the maximum score I could have had for that set of rolls and how many times I rolled the dice in that round. I am doing an average here. How many points did I score? It's random and volatile. So right now it's on average, I scored 20 points, but if I sort of re-enter something, so 20.1245, but now it's, another set of samples, and now it's like 19. How many times did I roll? This is typically five, so this is in the ballpark of 20, and this is in the ballpark. The number of rolls is in the ballpark of five, and then the standard deviation. I remind you in the video, this is strategies, um, and the strategy was sort of 20, so that's sort of consistent with what we're seeing. We're not doing strategies, but we're doing some sort of pre-strategy, but we see something in the ballpark of 20 is happening. But we also see, because I did the standard deviation here, that it's fairly spread out. And you'll also see that here, that it's, there is a maximum in there, but it's fairly like a bit horizontal for a while. So it's fairly spread out. And same thing for the number of counts. Okay, that's what I want to show you, my little pig die rolling simulation in Excel. Thanks for your attention.